Hello again and welcome back to Big Data Week in Chicago. My name is Sebastian James. I'm the city leader here for Big Data Week in Chicago. And up next is Dr. Phil Shelley of Newton Park Partners. He is going to talk about which is better, data warehouse or data hub. I've got a feeling it's the other one. But anyway, here we go.
Thanks, Sebastian. Hi, everyone. So I'm going to spend 20 minutes here going through some concepts around a data hub. I will talk about data warehouses, and they're certainly not obsolete, but there is some changes in the landscape. And the data hub thing is a concept that I need to go through quite a few slides to build up the story, so bear with me as I do that. First, a bit about me. You may or may not know me. If you don't, then I've been a CIO or a CTO for 15 years. I've been heavily involved in the last 5 years in the big data space, especially Hadoop in large enterprises. Myself and colleagues are working to help Hadoop implementations in other companies. We're doing Hadoop implementations, NoSQL, migration of workload from mainframes or data warehouses or traditional relational databases to Hadoop and NoSQL solutions. So some of the things you're going to see here are based on our learnings over the last few years, and please follow up with me. The last slide will have my contact information. We're more than happy to follow up with questions or anything else you want to know. So the data hub is something that we've thought about for many years. In fact, for decades, we've wanted to put all of our data in one place to do analytics on it. It's been very difficult to do that. Historically, systems were either too expensive or too constrained in terms of storage or processing power to put all of our data into one single hub. As you see as I build this story up, now we do have the tools, thanks to the good people from Google and Yahoo and Facebook and other people, Twitter. These people have donated fantastic open source technologies to the community that we can now leverage in traditional enterprises to do things that we historically just couldn't do. So this has been our challenge in enterprises for decades, and still is in many enterprises. We have many silos of data, dozens, maybe even hundreds in large companies of silos of data that have been copied one from another, and it makes it very difficult for analysts to do discovery on the data or analytics. Conversely, when we look on the right side of this slide, if we can get a single copy, single point of truth, full detail, full history, in as near real time as possible in one place, we can discover tremendous value from data that we couldn't historically do. This is the whole point of building out a data hub, and this is the story I'm going to develop for you. First of all, ETL. Many of you know what ETL, some people probably don't. ETL is just a term that says we're going to extract, that's the E, we're going to load, that's the L, and we're going to T, we're going to transform data from one system to another. Historically, and even today, transactional systems are not capable of sustaining the analytics workload. So we copy the data from the transactional systems into an analytical system. That's what ETL does, or one of the things ETL does. ETL is something that is very expensive to run, expensive to license, set up, administer, and is very time-consuming. We have lots of copies of data. We may copy data from one source, then we may recopy it many times and reuse it. The lineage of that data is sometimes very difficult to understand. We may have sales data in different formats with data stripped out, data added in, and it's sometimes very difficult to make sense. And it's a skill job to maintain an ETL landscape. So as we start to modernize around these data hub concepts, ETL still may exist in some form, but we're really going to transform the way we handle data. We're going to take our data from transactional systems and put them in a data hub in as near real time as possible. That may be a few milliseconds, literally, or it may be seconds, or it may be a few minutes. But it's still not like a traditional ETL system. We want to stream data into an analytical system as near real time as possible. We still may put it into a legacy BI system for some use cases. That is not going away. The data warehouse itself is not going away overnight, but the role is starting to change. Now, this slide I've been using for about the last 2 years or so, and I'm saying that if you're doing a modern enterprise landscape, data landscape now, we still have a need on the right side for traditional high-speed SQL environments. We're starting to see in that space now in-memory databases the last few years. And we still have the role of enterprise data warehouses, where we need high-speed SQL, BI tool support, drill down, relational structures. That's what we've seen for many, many, many years. But on the left now, we have new tools in the Hadoop stack, massively scalable, much lower cost, great for batch processing, very fast key value stores in the form of HBase or other NoSQL stores, very, very flexible data models. And we can keep full history, full detail, and make marts of it and make a lot of sense. By putting these two together, we've had a good solution. Now, in the last few months, literally since November last year, actually, this design is starting to be challenged. And I'm going to take you through a few slides that will explain why. So if we look back a few years ago, I just arbitrarily chose 2007. We didn't have to go in most enterprises at extreme speed on the left side. If we had queries that would run in a second or two, we were pretty happy. On the extreme right side of this slide, we didn't have to worry necessarily about petabytes of data. Most large companies could get by on analytics on a few hundred terabytes. That's starting to change in the last few years. If we just look at last year alone, on the left side now, we're starting to need to go very fast. We're starting to do real-time analytics. So we're starting to use in-memory databases. We still have the traditional enterprise data warehouse, traditional SQL in the middle, taking up the lion's share of our analytics workload. And now we have Hadoop. We have Hadoop fully matured and in use in many, many companies now to handle a very large scale, full detail, full history. Now, something just changed in the last few months that's starting to challenge this picture. What just happened was we have early adoption now of in-memory actually on Hadoop. So we can now run high-speed in-memory analytics on Hadoop itself. At the same time, Hadoop is getting more mature and still able to scale just like it was. So the role of the traditional data warehouse is starting to be squeezed from the sides. And it's still very valid, still has a use, but it's being squeezed. Now, you see that only today, actually, in the news today, if you have been watching, our friends at Teradata, their stock price just hit a 4-year low and went down 13.5% this morning. That's because there's pressure on those traditional data warehouses from these open source stacks. The way I see it going, and as it's maturing now, is the traditional data warehouse is still important for some workload, but it's going to be shrinking down in terms of need. Hadoop is growing, ever more popular. NoSQL's maturing. In-memory on Hadoop is growing more popular. Just recently, SAS has just launched their new tools running in-memory on Hadoop, letting you use normal SAS tools. There's a company with a product called H2O is doing the same for algorithms from R running in-memory on Hadoop. So this picture is really changing just almost month by month. Now, another way of looking at this, the slide I like to show people is this one. Data warehouses or SQL databases have historically, for decades, have performed really well in this kind of a zone. The green zone is where they're great, right? Very fast, high-speed SQL, milliseconds or seconds, or even just a few seconds on reasonable-sized data sets. Once we get into the petabytes, though, they start to be very slow and difficult to manage. Hadoop came along. Now, Hadoop historically has been very poor at high-speed queries, but it's been great at handling large data sets and large queries that don't run forever if they're well designed and the data's architected well. But we have this gap at the bottom where enterprise data warehouses still were, the king of the hill. Now, thanks to Facebook, our friends at Facebook just open source Presto, which is the replacement for Hive, the SQL engine for Hadoop, which is about 10 times faster than MapReduce SQL. We're seeing some really good early results with Presto, and it's starting to close the gap where Hadoop with Presto can do quite a lot of traditional workload. And now, the last few months, literally the last few months, we've started to see in-memory on Hadoop. Now we can get microsecond and millisecond response on data that's residing on the Hadoop cluster. And that is really starting to change the paradigm. Now you can see that that stack of tools is pretty much covering up the entire landscape for our analytics workload. So why would you use big data tools from an enterprise IT perspective? Well, first of all, to be responsive to the business. Business is asking IT to be more and more responsive, more and more access to data, more history, and immediately. ETL is very complex, and offloading ETL to a Hadoop data hub model really saves time. Latency in data from the time the data was created to the time you can do the analytics on it used to be days, then it went to hours, and now with these data hub concepts we're going to seconds or even milliseconds in some cases. Long-running workload can be moved to these data hubs. They're very powerful batch processing engines, and we can offload mainframes and data warehouses that are running batch workload or ETL workload and go a lot faster for a lot less money. And then modernizing systems. Big savings in modernizing expensive systems by using these open source tools. From a business perspective, we're focusing on new business capabilities, building a new business or a new product, testing a hypothesis or discovering value in data. The discovery tools for machine learning or data mining and text analytics, clustering and heat mapping and looking at linkages, finding hidden value in data. Asking previously impossible questions, and then moving towards real-time analytics and discovery. So now, let's look at a data architecture with a data hub in mind. What does it look like? First of all, we need an enterprise data architecture itself. Somebody has to govern this thing, and then you have to rethink your ETL model with the big data concept in the context of big data. We need to think about reducing our latency and enabling self-service for business users. We need to still have data stewards. We still need the right security, the right data modeling, the right architecture, and we have strict standards around the data sourcing. But it's going to be a hybrid. This data hub I'm going to show you now is a hybrid of tools you can put together to answer high-speed SQL, very high-speed in-memory, batch processing, and an intelligent archive. So let's look at a hub concept. I'm going to go through a few slides here fairly quickly, and then hopefully you get the idea. It's an ecosystem of tools. We're going to have data going in and data going out. Going in, we have transactional systems producing data. We may have a batch processing area. We probably do. Most companies do. We're going to have a service bus, if you have a service bus, where we can bring data in real time. If we can bring it in real time, we can do real-time analytics. With Storm or Apache S4 or other tools, we can do real-time analytics, and we can put it in real-time databases for that high-speed analytics work. We can bring the whole detailed set then into a data hub, full detail, and eventually into tables and marts that make sense to the business. We can push data out to in-memory or data warehouses. We can use Spark or in-memory tools that are commercial, or like SAS, for example, to do that. We may want to have high-speed data marts. We can use traditional tools like a SQL database, or we can use the NoSQL databases for that. And we may have temporary data marts that are transitional, where we are exporting data. And finally, we'd have persisted marts, all in this ecosystem where users can access that data with the conventional tools or with new tools. The idea is here to, and this is very small text, I'm not sure you'll see it on the video conference. The idea is to source the data once and then to drive up the reuse. Source the data once in real time or as near real time as possible, and then drive up the reuse of that single source. And we reduce latency, we reduce the number of copies, we reduce traditional ETL, and we have much better capabilities to do deep insights into that data. So that is the Data Hub story. It's very quick. I've gone through it super fast. That usually takes me an hour. My contact details are on there. Please feel free to copy me on anything you want, any questions you have. And that is it. Thank you, Sebastian.
Thank you so much, Phil.
Pleasure.
Pleasure. All righty. And now, coming up soon, Ankur Gupta of Metascale talking a lot about big data made easy. We'll be right back in a few minutes. Bye.